Hi, everybody, and welcome to our webinar on ClickHouse disaster recovery. We're going to be talking about tips and tricks to avoid trouble in paradise. My name is Robert Hodges. I'm CEO of Altinity. I've also been working on ClickHouse for about 6.5 years and databases for 40. I have with me Alexander Zaitsev. He's our CTO. We'll do deeper intros in just a second. Before we get into this, I just want to give you a couple of housekeeping things. They are, number one, this webinar is recorded. Let me just double check that that's really true. Yes, looks like we're recording. The second thing is we will send you a link to that recording as well as a slide deck as soon as this is done. Well, you get it within a few hours. It's as soon as we can get it up on YouTube and make sure everything's ready to share. Thing number three, we are here to take questions and help you through this complex issue. If you have questions, please feel free to note them in the Q&A answer box. That's probably best, but you can also put them in the chat. We'll see them there. Feel free to put them in at any time. If it's relevant, we may jump into them. Otherwise, we'll hold them for the end, and we'll do our level best to have a nice Q&A period at the end. Speaking of Q&A, one final point. A number of you sent me questions through LinkedIn when I reached out to you. Thank you so much for that. We'll try and cover all those questions here as well. With that, let's dive in. That's all the housekeeping out of the way. And let's do some intros. I've already introduced myself, database geek, working on open source for getting on to 2 decades. Alexander Zaitsev. Alexander, do you want to just give a quick intro on your background?
Hey guys, I'm Alexander. I'm co-founder and CTO of Altinity, working with databases for many years, and including some interesting disaster recovery scenarios. Can you hear me?
Yeah, can everybody hear us? I see somebody, if somebody can confirm you can hear us, okay? Yep, I see. Okay, for the person who can hear, I think it might be a local issue. Please go ahead, Alexander.
Oh, that's it.
Okay, great. So Altinity, you've probably heard of us before. We've been working on ClickHouse for since 2017. We're the authors of Altinity.cloud, first cloud service for ClickHouse in Amazon, GCP, most recently Hetzner. We also run in Azure. We are the authors of the Kubernetes operator for ClickHouse, which many of you on this call are already using. We maintain the ClickHouse backup project. It goes on and on. So we are big on ClickHouse. We love it, and we'll be sharing the knowledge that we have both from running the cloud as well as working with hundreds of customers over the years. Let's dive in. I'm going to take the first part of this talk, and I'm going to start with the basics. What is disaster recovery? And we're going to just give a kind of an overview of the options for ClickHouse installations. So disaster recovery. I found this great definition out in the Google Cloud documentation. They've been doing this for a while. It's basically your ability to restore access and functionality of services when something really bad happens. And really bad can span a variety of causes. We'll look at those in a second, but the point is to be able to, this is some event which just takes out a key part of your infrastructure. You need to get it back up and running as quickly as possible. So disasters come in all kinds of different sizes. We sometimes call this the blast radius, which is the idea of how far does this disaster reach? And in other words, and in fact, more importantly, how far away do you have to have copies of data when something bad happens? So you can think of these as being in kind of a hierarchy, roughly. They start with very simple things like, but simple and local things like a DBA drops a table by accident. People don't always think of that as a disaster, but you'd be surprised how often it happens. This is something you want to protect against because it may, when this happens, it may cause your service to crash, and you need to get it back up again as quickly as possible. They extend to node failures, node sort of machines and the racks that they live in, sort of local things, for example, storage failure that affects one or more nodes. They can go all the way up to an availability zone, which if you're a cloud person, you know that this is basically a big data center that's somewhere, out in Virginia, for example, it could be hit by a tornado or hurricane and be down. And then finally, there's full region outages. When these occur, they're not super common, but when they do occur, they can be because the cloud provider itself that you're on has a management plane problem, and key services that you depend on are simply down and you need to operate in a different region. So disaster recovery has to take care of all of these. And there's a lot of questions that you want to think about when you're dealing with this. For example, how much data can I lose? And this is something that we call the recovery point objective, or RPO. Very common phrase. How long will it take to restart the service? So, once you've thought through how much, avoiding data loss or minimizing it, you want to think about how quickly can I get back up and running? How much is it going to cost to do that? And how much complexity is it going to add to my installation? These are all key questions that come up when you're trying to solve this problem. By the way, as we're going through, I know many of you have joined. Please feel free to post questions in the webinar chat or the Q&A box. We'll answer them as we go along. So let's look at the answers to those questions. Well, in this talk, we're going to consider 4 different ways that you can handle disaster recovery with ClickHouse. They include backups, single region replication, cross-region replication, and independent clusters. That is, clusters which don't have direct replication between servers. And this handy table here summarizes the benefits and the drawbacks of each of these. So, for example, backups are the cheapest and the simplest to implement to protect your data, but they have downsides. Big one is that when you have to go to backups, if it's a big table, it's going to take a while to come back. And since backups only run at intervals, unless you have things very well organized, and we'll talk about one way to handle that, you may have a large data loss window. You can go to the other options. Single region replication is so easy to set up that it's something that every installation should do. We'll demonstrate that. Cross-region replication is more complicated, but it also covers you from large-scale disasters. And then independent clusters give you some creative ways, to handle DR at the cost of issues like data drift between the different clusters. We're going to dig into each of these as we go along. So let's start with the first one, backups. And we're going to, at the very end of this, deal with a trick that you can use if you're concerned about the data loss window that the ClickHouse users have used over the years. So what do you need to protect in ClickHouse? Well, this is a useful question to ask because sometimes people only think about the data, for example, in the tables, but there are other things. When you want to restore, you want to make sure that you've got all your configuration files. You'd like to replace those. You want to restore the schema for your tables so that when the tables come back, they have a place to live. The data itself is obviously important. And then RBAC metadata, in other words, things like system accounts, these we want to be able to cover as well, including special cases where you can store them in ZooKeeper. By the way, that's a really great feature. If you're not using it, you should look into it. So there are a number of options for backup and restore. One which is not widely used, but people have used this in the past to make copies of data, called ClickHouse Copier. It's not super well supported anymore. And it also doesn't handle things like backing up or copying your configuration files or user accounts. There is the Altinity backup for ClickHouse. That is sometimes known as ClickHouse Backup because that's the name of the project in our org. And it's a standalone backup utility for ClickHouse. It's been around for years. We've maintained it through many, many versions. One of the things that's cool about it, and we'll have a more detailed comparison, is it backs up everything. And then finally, there is ClickHouse Backup and Restore. So there's built-in backup and restore commands in ClickHouse itself. We'll also explore those. They don't back up as completely, but they also have some couple of neat features that you should look at. So let's look at ClickHouse Backup. It's a command line tool. It's written in Go. You can just download it and get started. Very, very simple to to work with. And this example here shows you how do we create a backup. So basically, what we do is we issue a create backup command, and that's basically going to make a local copy of your data that is constructed using hard links. So it takes no extra storage space, but it basically gives you a stable copy of the files that you can then go ahead and upload to remote storage, typically object storage. These commands can be combined into a single command, which will just do the whole thing at once. And what will happen is you have this shadow copy. It just remains out there until everything's uploaded, and then you can wipe it out, and and there's no evidence the backup occurred. How do you get it back? You restore it. So you basically reverse this process where you download the files from the remote storage. That creates a shadow copy, and then the restore command moves that shadow copy back into the ClickHouse server. This can be used to back up and restore not just full databases, but it can also do tables as well. It can also do parts. It's very versatile in the information that it can back up and restore. There are a bunch of different restore options. These are just some examples. So restoring schema, for example, if you just want to recreate the schema on another cluster, you may use this in recovery sometimes if you're restoring replicas, but it can also make a copy of the schema in another location. Restoring single tables, restoring partitions within tables, so on and so forth. If you go to the project repo out in GitHub, there's a nice documentation page that shows you all of this. And the backup, ClickHouse Backup has a pretty good help built into the tool. So it's very easy to figure this out. The other backup option is to do what we call the embedded backup, which is SQL commands that are written into ClickHouse itself. So they're very simple. So you basically say something like backup the database, you give the database name, and you send it to a disk. So it's an external storage location. And then you can restore it from that location. And like ClickHouse Backup, this also supports restore of individual tables. So it's pretty much if you look at it, it's the same functionality, as far as backup and restore, except that it's embedded within ClickHouse itself. One interesting tip, which I didn't put in the slides, is actually ClickHouse itself can work as SQL commands. There's a special table that you can set up, and if you just insert a row into this table, ClickHouse Backup will see it and treat it as a command. So in both cases, you can have the backups run from within ClickHouse itself. There is a really cool feature which was recently introduced. It's in 25.2, so that's the February version of ClickHouse. It's called the Backup Database Engine. And this is really neat. What it allows you to do is take a backup, mount it as what appears to be a database, and then you have the tables. And so you can actually run queries off these tables. They could be stored out in object storage, for example. So you can do queries on them. And of course, if you need to do a restore, this makes it very simple. You simply select the data out of this into wherever you want it to be restored back to. So cool feature. That's one that I think we need to look at how ClickHouse Backup can support that too. Really cool. So which of these tools should you use? Well, here's a table that gives you some of the basic options. In general, ClickHouse Backup is more versatile. So for example, it works across many ClickHouse versions, whereas the built-in commands, what you get, depends on which version of ClickHouse that you're using. It also does some kind of interesting things like running, like backing up backup settings, or excuse me, RBAC information, including when it's stored in ZooKeeper or Keeper. And it also has some built-in automation features. In general, if you're trying to automate something or you want something that'll work across different server types, ClickHouse Backup is a good one to look hard at. I will say one other thing about it. We've used it in Altinity.cloud now for years. It's our backup mechanism. So this thing gets pounded on every day. The SQL backup, the big advantage is it's baked into ClickHouse, and then it has this cool feature like the backup database. So you can definitely look at these and sort of consider which one works for you, but they're both interesting and useful. So backing up ZooKeeper, this is an important thing to think about. Of course, ZooKeeper has a notion of backups. You can copy the snapshots. If you want to restore the backup and restore the RBAC information, as I said, you can use the minus RBAC option on ClickHouse Backup. So that will both copy it if you're doing a backup or restore it. And then there's a really key command, and this goes to a question that we received out of LinkedIn, system restore replica. This is a command which, if you operate ClickHouse, you should know it. What it does is it takes a replica which has gotten disconnected from ZooKeeper, for example, or has somehow lost where the ZooKeeper metadata has been lost. What it does is it restores the metadata in Keeper or ZooKeeper by just looking at the contents of files on disk for that server. It just puts it back into ZooKeeper. It's a really great command, and it means that even for a large cluster of ClickHouse servers, you can always get back ZooKeeper metadata just by going out to the individual servers and reloading the metadata. So there's a description of how to use this in in our KB, which we'll reference later. And one final thing, backups have this problem that, as you're probably aware, you have a data loss window. Now, you can partially address that with incremental backups, but even incremental backups are expensive to run. They use CPU. They only run at intervals because ClickHouse doesn't really have such a thing as a log. But if you're using Kafka or Redpanda, you actually have a log already built in. So one thing that some companies do is in their backup script, what they will do is they'll just have a fully automated process where they first of all stop the ingest. They take the Kafka topic offsets if they're using Kafka, and they put them in a ClickHouse backup or a ClickHouse table. Next, wait for the replicas to sync so that you know you've got a consistent copy, and then go ahead and run your backup. And as soon as the stable snapshot is created, you can re-enable ingest and start again. So it's kind of like a brief period of time where you just need to get a stable copy, get the offsets. It's in your backup. So then when you restore it, what you can do is you restore the tables, and then you reset the Kafka topic offsets, and then re-enable ingest. And what that means is your consumers, which are reading off Kafka and then presumably dumping the data into ClickHouse, will go ahead and reread all the data that they missed. This is a really great option. How you do that is going to differ according to whether you write your own consumers, whether you do use Kafka Table Engine, but it's definitely something to look into. So that's it for backups. I do see people with raised hands. If you have questions, feel free to post them into the chat or into the question and answer. Let's look at the second option for this, which is cross availability zone replication. And as we saw from the table, this handles failures within single data centers. So you have 3 availability zones that corresponds to, for example, that corresponds to 3 data centers. They may be, say, 30 kilometers apart. So if there's a tornado, they don't all get hit at once. Let's see how to handle failure with that. So the basic way to handle this case is just to spread your ClickHouse clusters across multiple availability zones. So the networking is relatively simple to do, and I'll show you in a minute. This kind of works out of the box. Because the network latencies are low, you can run your keeper servers in different availability zones. They will be able to communicate with each other, establish consensus. You can ingest at high rates of speed. But if one of these data centers goes down, you still got 2 left. So this is something that kind of works out of the box. And one of the things that it's driven by is that there are features when we set up ClickHouse that we can use what's called affinity or anti-affinity, which basically force the ClickHouse servers as well as the Keeper or ZooKeeper servers to be in particular locations. So what anti-affinity does is it causes ClickHouse servers not to land on the same machine. Affinity can drive them to land on particular machines or in particular availability zones. So we can use these two properties to set up replication and replicas that span the availability zones. What's the simplest way to do this? Well, if you're operating in the cloud, I would highly recommend running this on Kubernetes and using the Altinity Kubernetes operator. And this is not just because we wrote this, it just happens that Kubernetes is very good at placing things in different locations. This is one of the reasons why Kubernetes is quite popular. And the ClickHouse operator gives you the ability to define your cluster with a relatively small piece of YAML that then gets read in. The Altinity operator will look at it, and then it will basically issue the commands to generate Kubernetes resources that will then place your servers in different locations across availability zones. Very, very straightforward to set up. Let me give you an example. So here's this is a ClickHouse installation. That's the standard resource type for ClickHouse and Kubernetes. It's a simple YAML file, and right here, this shows you roughly what these things look like. And the thing I want to highlight is we have this templates section. So and we have a pod template which says, hey, these are processes that are going to be set up using this pattern here, replica in zone US West 2A, and then there's another one for US West 2B. And if we go to the next page, we fill those out. So there's going to be, in this particular case, we're going to have 2 replicas for each shard. And what we'll see is actually in the pod template definitions, we're going to have some clauses, one of which is going to basically give us to basically force these in this particular case the replicas to be in a particular zone, in this case US West 2A. And then we also have some nice just one second. Sorry, temporary outage. So we also have features in the operator that allow us to have anti-affinity enabled by default. This forces them on different hosts. So this will prevent you from having 2 servers land on the same host. When you have this, you've basically got things spread out pretty nicely. Whenever you set things up like this, it's really important to make sure it really worked. So these are just examples of quick commands to see what hosts you're running on. You can build a script that does this a little bit more better, so you can confirm, yes, these two guys are running on different hosts. And then there's also a command that you can use to confirm that your hosts are in particular zones. This can obviously be scripted together so that you can give yourself a little report and make sure that your servers are located exactly where you expect. So with this, we've covered backup, which is the basic way to cover tables, and we've also covered multi-AZ replication. And I want to just talk about this. A great question comes up for Janet. Oz charges on cross-AZ data transfer and replicating AZs is the amount of data transfer 1-to-1 with the amount of data ingested. In general, yes. So what'll happen is the blocks will transfer across. The key thing you want to look out for, and it has bitten us in the past, and Alexander can add more to this, is if you accidentally have things configured so that when you do your ZooKeeper or keeper lookups, if those are going across availability zones, we have hit problems where that actually caused a huge amount of traffic going across AZs, in which case you're paying 2 cents a gig or something like that. So what you want to do is watch your network costs when you set this up. And then if you see something that's generating more traffic than you expect, go ahead and dig in, find out who's misconfigured, fix it, and keep going. Alexander, I'm going to turn this over to you. To talk about cross-region replication.
Thank you, Robert. But before then, I will add a couple of more words about cross-AZ traffic. So typically, the cross-AZ traffic for replication, it is even smaller compared to the traffic, compared to your ingest traffic, because the data which is replicated, these are already well compressed parts. All other operations that replication is responsible for, like mergers, etc., they are executed independently on every replica, and that kind of eliminates the extra traffic. But ZooKeeper may be a problem, or keeper, if ClickHouse talks to keeper in a different zone, that may generate surprisingly big traffic sometimes. Not always, but sometimes. Okay, let's talk about cross-region replication. So cross-region replication, we actually use it for two different purposes. One purpose is, of course, DR, because it gives you an availability site somewhere else in another region or continent. But another and very popular reason to have cross-region replication is kind of being closer to your customers. So say you have a site in Europe and you have a site in US, which are replicated. So customers from US, they may go to your US database, and customers from Europe, you can go to your Europe database. So in addition to high availability and DR, it also gives you a better, smaller latency for your applications. How to set it up? No, Robert, let's take back a bit. So basically, in order to set up cross-region replication, we need to do a couple of things. First, we need to configure network because services need to talk to each other, and they talk to each other on multiple occasions. Of course, ClickHouse needs to replicate data, and this is a special replication port on every ClickHouse server. Also, we may want to execute distributed DDL queries, and this is another port that should be accessible from both regions. So ClickHouse nodes from one region should see the nodes in another region. And finally, in order to replication to work, all the nodes should see the same ZooKeeper, or to connect to the same ZooKeeper. We usually don't recommend to have ZooKeeper located in two regions, and I will explain why. And in this picture, you can see that region A is kind of our main region, and here we have two replicas of ClickHouse, and also there's a ZooKeeper, which is responsible for coordination of your ingest, mergers, and so on and so forth. But in region B, we can also deploy so-called observer ZooKeeper, which is not acting until you have a DR event. And in this case, you can do switchover. Let's keep going. So how to set up a network? Because we are working in Kubernetes. We have two Kubernetes clusters, and they are located in different, what is called VPCs. Every VPC has its own subnets and so on and so forth. So it is not very easy to tie them together. There are multiple options that you can try, and maybe the easiest one, at least in AWS, is VPC peering. What VPC peering does for you, it allows you from one VPC see address space in other VPC. But this is not all. In addition, we need to make sure that DNS, not only the traffic is routable between VPCs, but also we need a way to refer to the services, because in Kubernetes, we always use Kubernetes services in order to configure ClickHouse, Keeper, ZooKeeper, etc. And if we have two clusters, they should see services from each other. Let's see how we can set it up. Next slide, Robert. So in fact, what we can do, we can modify the core DNS in both regions in order to fail over to the DNS server of another Kubernetes cluster. That requires a little bit of cloud configuration, and also it requires you to patch or modify the configuration config map, which is used by coordinate server service in every Kubernetes cluster. But if you do it, what it happens is the following: once you have a service name, ClickHouse, or no ClickHouse, Kubernetes tries to resolve it locally first. If it is resolved, that's fine. But if it's not, it fails. It does fail over to another DNS server, which is located in the different Kubernetes cluster, and that Kubernetes cluster may respond with the IP address for the service. So we kind of do this tying together two DNS resolution systems from two Kubernetes cluster, and that allows you to talk using services between Kubernetes clusters. One thing that immediately pops in mind, or should pop in mind, is that if there are name collisions, then you have a problem. If one name is resolved in Kubernetes cluster in one region, it cannot be resolved in another one, because this fail-through rule wouldn't fire. So we need to be very careful setting up different service names, and this is a requirement. Let's see how we can do it. So another challenge is that services in Kubernetes may be of two different types. Maybe if you're not familiar with Kubernetes in depth, this may be a bit overcomplicated for you, but I will try to do it as simple as possible. So there are headless services and regular services. The difference is that with a headless service, with a regular service, you have an IP address that the service resolves to. And whatever happens with underlying port, in our case it's ClickHouse, this IP address doesn't change. It only changes if you recreate the service. This is very reliable, but this IP address, it belongs to a subnet of the Kubernetes cluster. And therefore, it cannot be used with VPC peering. Instead, what works is to use headless services. The headless service, it doesn't have a static IP address. Instead, it every time you use this headless service, it routes directly to the underlying port. And those headless services, they work fine with VPC peering. So one thing that you have to do if you configure cross-region replication, you need to use only headless services. ZooKeeper installation, if you use standard ZooKeeper deployment, it already have headless service. If you use Keeper with ClickHouse operator, you can create a service template with a headless service. And you can do the same for ClickHouse itself. So basically, all ClickHouse services needs to be converted to headless ones. Next slide, Robert. And this is an example how you can do it on a running ClickHouse installation. So ClickHouse operator has kind of unique feature, which is called ClickHouse installation templates, which allow you to inject some extra behavior to your existing running cluster. So this particular template, it would convert the service for first replica to the headless one with this cluster IP non-property. So whatever you configured initially will be overwritten with this definition. Of course, if you can modify your ClickHouse installation directly, you can modify the service template directly. But if you cannot, then you can ingest this behavior additionally to what you have right now, to what you have already. And that's almost it. So once you set up VPC peering, modified core DNS, and converted services to be headless one, your replication already starts to work. What is left is how to make sure that you can easily operate with this cluster. And for that, you also need to create a special cluster across two regions. This is just a cluster definition that combines nodes from two different ClickHouse installations. I didn't mention it explicitly, but I think it was clear from the description that in every region we have a separate ClickHouse installation. So technically, every ClickHouse installation is different. They're just tied together with replication. It is a little bit more difficult to manage, but it is a small overhead for cross-region replication. And what we're also adding this demo cross-region cluster, which allows you to run distributed DDLs. So on the next slide, you will see it is pretty straightforward. It just combines the host names from two clusters from both regions in a one single cluster definition. And when you have it, you can run create table command, create table on cluster, alter tables, drop tables, whatever you need to run, and it will be automatically propagated to your both regions. Not easy, and it requires a lot of manual heavy lifting, but you can do it with open source tools. In Altinity Cloud, we plan to add some automation in the next few months that will make it much easier to set up, but you can do it in open source as well. So next slide. Finally, what you have to do if you have a DR event. First of all, this is really complicated. So when something bad happens, your first reaction should be to check if this is going to go away. So maybe this is some temporary network problem, and you will spend more time trying to fail over rather than waiting for network to get back. But if your primary region is down hard and you have no hopes to get it back in a foreseeable future or in your kind of application requirements, then you have to do failover. And there are two options here that you can consider, and both requires automation. So there are no standard tools to do that. So first of all, you can just you switch your users to your standby site, but since there is no ZooKeeper in standby site, your inserts are not working. It is available for queries, your dashboards are being populated with the data, but no new data arrives. So what you can do is the following. You of course stop ingest because your primary site is down. Then you start new keeper or ZooKeeper ensemble in your DR site. Reconfigure ClickHouse, because originally, if you remember, ClickHouse in our DR site was looking into ZooKeeper in our primary site. So you need to reconfigure ClickHouse and then run system restore replica on every replicated table. That will restore state in ZooKeeper, and tables will be writable after that. So you start ingest, and you're kind of back in the business. There are of course downsides. For some time, your tables will be in read-only mode, and that requires careful scripting. And you also have to iterate through every replicated table because system restore replica works on a table basis. There is a second option, which is a bit easier. You may have those ZooKeeper or Keeper observers in your DR site, and if DR event happens, those observers, they already have metadata, but they are not acting as a primary ones. So what you need to do is to promote them to the cluster, to the primary cluster, maybe disconnecting them as observers from your primary site. Reconfigure everything that needs to be reconfigured, and that's it. So after your ZooKeeper ensemble starts to be primary, your ingestion and inserts may be resumed. There are still downsides. It's not automated. You still need to do some automation, and for some period of time, you will be in read-only mode. And also, it is not very easy to do with Keeper. So in some cases, old ZooKeeper is still easier to operate compared to the new Keeper. So this particular scenario is very not straightforward to do with the Keeper, but it's possible. So as I said, this is really complicated, and you need to do a lot of testing and scripting to get it done. But we know several companies who did it successfully. Let me check questions. What is a feature that stores airbag and keeper? This is called user directories storage. So you can configure different storages for the users. The default one is XML. You can also use a local storage, which stores users and airbag metadata in a special storage together with your data. And you can also configure your users and airbag to be stored in Keeper. I don't remember the setting name, but we can send you it after the call. Additionally, you can also configure to store in Keeper or ZooKeeper some extra objects which are not tables, like UDFs and something else, but there are not too many. Yannick is asking about more Keeper cross AZ. So the problem, actually, the Keeper cross AZ is pretty straightforward. You just define anti-affinity rules and put Keeper in different zones. There is also a possibility to tell ClickHouse to connect to Keeper to the same availability zone. So ClickHouse itself, especially when it runs excuse me, in AWS, I'm not sure about GCP, it knows the availability zone. It can extract it from AWS environment variables. And you may configure when you define ZooKeeper section in your ClickHouse configuration for every keeper or the keeper node in which AZ you know it is running. And in this case, ClickHouse will try to connect to the keeper or ZooKeeper in the same AZ. That will kind of improve your performance and reduce costs. But again, that requires manual configuration. The question about failover, yes, it's not smooth operation. And unfortunately, there are no good automation to make it smoother because there are multiple approaches to do it. ClickHouse itself doesn't provide enough tools. We on our side, on Altinity side, we can do it easier to do in Altinity Cloud. So many things we already do automatically, like deploying into different AZs. We plan to start doing this zone-aware ZooKeeper connections and stuff like that. So eventually, we will go to make it easier to fail over as well. But if you run everything in open source, there are no good tooling available as a product or as a project that you can use, unfortunately. So you will have to do a lot of manual lifting.
Yeah, if I could jump in, there are plenty of people who've done this. So it does require scripting, but it's definitely doable. I think the system restore replica is your friend, because if all else fails, you can always recover the ZooKeeper metadata. The other thing I'd say, Alexander, is I think we owe everybody another blog article on top of your excellent cross-region replication to talk about to give some worked examples of the steps for failover, because it's a little bit tricky. And I think the key thing maybe to take away from this talk is if you do it with Keeper, there are some bugs in the reconfiguration commands that make it hard to do failover. So that's just something to bear in mind. Those are things that I think will eventually get fixed and it will become easier.
Yes, thank you, Robert. So we are getting closer to the end. So there is one more topic to cover, and it is called independent clusters. So basically, the last DR strategy, and at some extent, it is probably the easiest one, is just to set up independent clusters in multiple regions and multiply your ingest. So you kind of ingest independently in every site. I personally will implement it the first time almost how many 15 or 20 years ago, not with ClickHouse, but with some other databases. So this is universal approach, not just ClickHouse specific. So let's see what we can do. So say you have a Kafka, which makes it really easier, but it may be any thing that can ingest data and that allow you to ingest the same data into multiple destinations. So with Kafka, it's just easier. You may have a broker and your ClickHouse clusters, independent one, they are just different, connect to different consumer groups. So every cluster here, which is deployed in a availability zone or in a region or in different cloud, it could be even different cloud providers, they get the same data, and process the same data the same way, and therefore you may assume that they are identical. Of course, in reality, there could be some discrepancies. You may deploy schema be differently, or there may be some errors on one side, but on another that are not properly tracked. But in theory, both systems may be identical. So you just make sure that you have the same version of software, the same version of the schema, and you use the same data to populate. The next slide. Another interesting design that some of ClickHouse users have implemented is how to do a cross-region system that is tolerant to writes as well. So we in the previous section we explained how we can do failover to the system and mentioned that it will be read-only for some period of time. In fact, you can work around that, deploying the system which is displayed on this slide. So the main idea is that you have two subclusters, and for one subcluster, the primary region is region A. For another subcluster, the primary region is region B. They replicate to each other. Every subcluster have replicas in region A, region B. Every subcluster has ZooKeeper in the region which is primary for this particular subcluster. Then, in order to have a full data, of course, you can define a distributed table that collects nodes from both subclusters. And in every region, you have a consistent full view of your data. If something happens to region A, you still have a full data, and you still can do writes. You can do writes only to one subcluster, but who cares? You still can do writes in region B if region A is down. Similarly, if region B is down, you can continue to do writes in region A, and you still have the full data copy in region A, so you don't have an outage. So this design, it is better in terms that you don't need to do failover immediately. You can decide later. You have some time to think if you need to do failover, or you can recover your region which has failed, but at the same time you still in operation. Let's keep going. So maybe Robert, you can take from here.
I'll take over. Thank you so much, Alexander. So we're at the end of the talk. Let's do a quick summary, and then we've got more questions queued up, so keep them coming. So just looking back over these different approaches to DR, we covered backup. It's the cheapest, and you always want to have backup in some form because it handles drop tables. Anything else that's replication based, if you do a drop table, particularly on cluster, it's gone, and you're not going to get it back unless you have a backed up copy somewhere. Yeah. So definitely something to to think about in your DR stretch. And then you can choose one of the following. First of all, the cross AZ DR, which the Kubernetes, the Altinity Kubernetes operator makes this really easy to set up. It's something that, there's a few minor details like just making sure you don't get cross AZ egress costs, but it's so straightforward that if you care about, if you're running a cluster in a, Amazon or Google or Azure region, you should just have this configured. The cross-region DR, the biggest, that gets you, coverage in case the whole region goes down. The hardest part is the custom networking setup, followed by the failover, but it also works. And then finally, you have these kind of creative alternatives which reduce the RPO and the RTO and simplify the management. And I think the final example that Alexander gave is really elegant solution that as long as the regions eventually come back, should get you through most disasters, big and small. I really like that one. It's kind of a cool way of thinking about it. As we mentioned, Altinity.cloud is adding full support for cross-region DR by Q3. And if you want to find out more about this, aside from sticking around and asking us questions, check out the Altinity blog, the Altinity YouTube channel, ClickHouse docs. They cover the built-in backup. And then, of course, if you get really lost and have to figure things out, the ClickHouse source code is a really important and useful source of information. I'd like to refer you to two really important sources of information that we've provided. The first is on the Altinity blog. Alexander wrote an article called Setting Up Cross-Region ClickHouse Replication Kubernetes. That's where the slides for the cross-region replication, all the examples are based on that. If you go look at the article, you'll have a lot more information, particularly about the network setup. The other thing I'd refer to you is a talk we did recently about ClickHouse Backup that covers how ClickHouse Backup works, all the details, ins and outs, covers things like incremental backups, stuff like that. So if you want to find out, aside from reading the docs and downloading it and trying it out, check out that YouTube webinar. I think you'll find it very helpful. And if you're looking for an easier way, this probably goes without saying. We've mentioned it a couple of times. Check out altinity.cloud. Most of the things that we've described here can be, particularly the DR is something that we're going to be adding support for. The cross-AZ replication is enabling just by punching a button, basically. So check us out. We have lots of happy users, and we'd be happy to add you to the list. And then the final thing is, talk to us, and you can do that by coming to the website. There's a contact us. You can set up a meeting if you're interested in this, or you can come to our Slack. It's a really great place. It's in fact the only place I can talk to you because I somehow managed to get banned from the main ClickHouse Slack. But come talk to us, and then of course the obvious way to talk to us is ask us some more questions here. We've done a good job here. We've still got some extra time. Alexander, why don't we go ahead and just go through some of these questions here, starting at the top. Are there any plans to support multi-cluster deployment for Altinity ClickHouse operator, especially for DR purposes? You want to comment on that one?
Yes. Actually, I'm not sure I understand the question. So Altinity operator, it allows multi-cluster, or is it the question about
It's more like a super operator, like what eBay did.
Yeah.
With
Yeah. So operator itself cannot do multi-Kubernetes cluster deployments because it operates in a single Kubernetes cluster. So if in order to do it across multiple Kubernetes clusters, you have to do something which is outside, which is sitting outside. The good example of that has been done by eBay. Unfortunately, it didn't open source their work. What they did is they did a special resource which they called ClickHouse federated installation, or federated ClickHouse installation, and that described this super setup across two Kubernetes cluster. the special operator for this federator ClickHouse installation, it was responsible for making sure that it maintains ClickHouse installation resources in a proper state. And then they had some deployment process that they used to deploy this federated ClickHouse installation in 2 different Kubernetes clusters. So it is not ClickHouse operator that exists in its current form. It requires a different operator, but of course it's possible. We didn't do it only because this multi-region DR scenario is pretty rare, even now. But yes, we totally agree that it requires better automation.
Yeah, and one thing I would add is that the Kubernetes operator is a completely open source project. We take PRs from all over. If you'd like us to help us build something like that or work collaboratively, come talk to us. This is a request we've had over the years. We're definitely up for working on it. I think it would have a lot of benefits. Alexander, so I just want to confirm you had the question from Yannick on cross AZ data transfer. It should be 1-to-1 on the amount of data ingested, correct? Unless you're pulling parts, which we don't do.
It should be less. I think I
Yeah.
touched it. That should be less because the data which is ingested is typically bigger than the data which is stored due to better compression ClickHouses.
Yes, thank you. Obvious point. So if you get 90% compression, what will happen is the initial blocks that hit your table, yes, they will be replicated, but only 10% of the data you actually saw going in. So it's better than it sounds. And when we do replication, for example, where we rewrite parts, those don't get those get repeated in different AZs. Here's a question. Here's an interesting question. Rather than working with core DNS, would it be possible to achieve the same outcome using the ingress gateways for both clusters?
Maybe, but we tried to find some solution that can be deployed with any cloud providers.
Yeah.
And the ingress gateway is something AWS specific.
Yeah, that's a great point because also, since everybody has core DNS, one of the things we've found, because we now operate Kubernetes across 4 environments, and then of course deal with users who do even more. The more stuff you can just build using native Kubernetes resources, the happier you are. Because an ingest is the place where, or excuse me, ingress is the place where the cloud providers have the largest differences in their distribution. So you could put something together that works in Amazon and just wouldn't work at all, or be extremely costly in some other cloud. So I think that's a really key point for designing these systems. Here's one. Is it good to keep a ZooKeeper in every cluster or to have ZooKeeper separately in a VM? I'm not sure I totally understand that, but this is one where keep ZooKeeper or Keeper on a separate VM and don't have other workloads on it. We also recommend strongly not sharing keepers or ZooKeepers across ClickHouse clusters, because what will happen is if one of your clusters goes crazy or one of your clients of ZooKeeper goes crazy and starts putting a lot of load on it, it can cause your tables in other clusters to go read-only, and that is bad. Read-only tables is because then it'll stop ingest across the board. Ingest depends on ZooKeeper being alive and well. So I think it's important you just put keepers in a corner, feed them well, and you'll be happy. So it's really not that big. They don't actually use that much compute typically. So putting them separately is not in separate clusters is not going to be too expensive. Okay, so I think we addressed the issue. Current failover is not really smooth operation for production. Do you have a plan to make it better operationally? The plan is, put it into Altinity.cloud. Let's see. What's the smallest unit for backup? A partition? How to back up if a partition is very large? Alexander, I think you're answering that one.
Yeah, I was going to answer. So if your partition is very big, you are actually in a big trouble, not only for backups. because your mergers may be also not very good and everything else. So first of all, try not to be in a situation when partition is really big. ClickHouse has some recommendations on the partition side. But if you are in this situation, then you have to accept that backup might take quite a lot of time. So if you need to back up all your data, you just don't have any other choice. Maybe the only other option that you can take is just to use click select insert to some remote destination with appropriate where conditions, but this is not full your data, it's just a partial data.
Yeah, hey, there's a great question here about undrop table. What about undrop table if drop table was executed without sync? Are we able to recover a big table fast using this option? Alexander, you want to take this one? That is a great question.
It doesn't depend on the table size. So if you drop table and you have this undrop behavior enabled, then the data is not physically dropped for a certain period of time. ClickHouse actually tries not to delete data, not to delete inactive parts for 8 minutes by default. And this is kind of the same. If you immediately recognize that the table that you just dropped is still needed for something, and then you can undrop, but you don't have a lot of time. So I wouldn't rely on this as a DR scenario. This is
not if your job depends on it.
Yep.
The other thing is ClickHouse has some you might call trigger locks in that prevent you. There are system settings that set the largest table size that you can just issue a drop table on. And so to drop a big table, you're actually going to have to increase them. So you really have to go out of your way to destroy big tables. It's sort of like small to medium sized ones that you can actually delete and just have them disappear. So that was a great question by somebody who really knows how ClickHouse works. Let's see. So I think, Alexander, it looks like we're at the end of our questions. Somebody did ask about insert quorum out on LinkedIn. I'll just say that ensures that copies of data get to multiple servers. It is helpful what it basically does is protect you against a case where the data is trapped on a single server and you lose storage. But it's kind of costly to do. It does not help you necessarily with ZooKeeper data. When ZooKeeper data or Keeper data gets messed up, the thing to do is to do a system restore replica. We use that a lot. So you always as long as you don't lose the servers, you usually can recover. ClickHouse is very robust in that way. I think a lot better than many other databases I've worked with. Sasha, I think we're done. We're over time. Folks, I'd like to thank you for attending this. It's been really well attended webinar. We hope it was useful. Please do come talk to us. Join the Altinity Slack. Contact us directly if you want deeper, sort of deeper advice on this. And there's obviously, and if you're looking for interesting automation to do, there's some really interesting problems to solve in this space. Please solve them, contribute code out into open source, write blog articles, tell us how you did it. And we'd love to collaborate with you on making ClickHouse better for everybody. So thank you very much and have a great day. And Alexander, thank you so much for your help on this webinar.
Thank you, everybody.
Talk to you soon.
Bye-bye.
Bye.